plus 1 equals to 0, x plus 2y plus 3z minus 2 equals to 0. These two are homework methods. Okay. Now documents, today's document. Okay. Okay. For the next topic, like sorry, Gauss-Seidel and Gauss-Jacobi. Okay, now. So so for that one, iterative methods, you need actually calculator. Without calculator, you can't find the solution. Okay. So either calculator or mobile, anything, but spare mobile you need, I think so. So now fine. Okay. What is the next topic? Okay. Gauss-Seidel. So these are iterative method. Okay, now. So these two, wait. Okay, before that, okay, Gauss-Seidel and Gauss-Jacobi. Okay, both are these two are only there. Yes, Gauss-Jacobi. Okay, or simply you can say Jacobi method. Okay, Jacobi method. Okay. So first we'll consider this one, then Gauss-Seidel. Okay. Gauss-Seidel. Okay. Next one. Okay. 1 minute. This one. Make it ready. Okay. Ha. Actually, first we have to study Gauss-Jacobi. Okay, now. Gauss-Jacobi. Sometimes this method is known as simply Jacobi method. Okay. That Jacobi method or Gauss-Seidel method. Okay, now. Gauss-Seidel method. Both the cases. Okay. For both the cases, you have to both the methods are iterative methods. Okay. What is the meaning of iterative method? Be quick. What is the, if you have any idea about iterative method, what is the meaning of iterative method? Anyone? Okay, okay, fine. So if we say like in different words, like say you have the first solution, means one solution you have. Okay, you have one solution. Now same procedure, using the same procedure, okay, either this one or any iterative method. Okay, now if you want to improve this one, okay, say this is the improved one, second solution. Okay, so second solution, for the second solution you must use the first solution as an input. Okay, so that means this is your first solution you have obtained using the methods, okay, any method. Okay, and to improve this solution, that means in the second solution you have to use the previous solution as an input, okay, now. So similar case, third solution, what is the input? The second solution. Second solution means the previous solution. What is the meaning? Now ultimately, now you are using the previous solution, okay, as an input, or In other words, you can say that the previous solution, you are improving the previous solution using the same techniques to find the better or close to the original solution. Okay, so this is the meaning of iterative method actually. Now to study this too, actually you should have some basic concept. That one is dominant properties. What is that dominant properties? That is called diagonal dominant property. Diagonally dominant property. Dominant properties. What is that property actually? Okay, just 1 minute. Actually, I have to send the mail to say first year CE. First year mechanical. Yeah. Fine. Just 1 minute. Huh? What is diagonally dominant one? I have to inform that. Yeah. 1 minute. Actually, civil department first year. Today they're CT1, so just inform them that I have sent the exam. Sorry, question paper. Fine. Okay, so now diagonally dominant properties. Okay, so diagonally dominant property. What is the diagonally dominant property? Okay, first of all, let us consider the system only 3 or 4. Okay, so A11, okay, x1 plus A12 x2 plus A13 x3. Okay, let us see. A1n xn equals to V1. A22 x2 plus A21 x1 plus A22 x2 plus A23 x3 and so on. Okay. A2n xn equals to V2. And finally, AM, if you consider, say, let us same, okay, now, yn, n1 x1 plus an2 x2, an3 x3, number of equation equals to number of xn equals to vn. Okay, so what is the diagonally dominant properties? Okay, so what are the diagonal elements? Here the diagonal elements are this one, correct? And so the diagonally dominant properties is that modulus of A11, okay, if it is greater than or equals to the sum of the other elements, okay, and it should, this concept should be true for all the rows. What about the other then? So this is for the first row, correct? No? Diagonally dominant means all the diagonal elements is greater than or equals to the sum of the other elements of that row. Okay. So A22 equals to mod of A21 plus A23 plus plus A2n. So similarly, okay, last one is the AN in n. Okay, it should be greater than equals to AN1 plus AN2 and so on. ANN n minus 1. This one. Clear? So what is the diagonal element? In mathematical form, AII is greater than equals to sum of A modulus of ij. Okay. So you tell me what will be the condition here? I not equals to j. You just say right hand side there is no A11. Correct? And what is the value of j? J is from 1 to n. So it is true for all n. Okay, for all I. Correct? If this one is true for all I, this is the mathematical form or mathematical expression for the diagonally dominant properties. Okay. Is it clear? Yeah. So if any system, okay, if any system which is not a diagonally dominant system, then you can't apply these two, Gauss-Seidel and Gauss-Jacobi method. Okay. So now next page. Okay. Let us consider one problem. Okay, now just for checking, is it diagonally dominant? That means, can we solve this system using the Gauss-Jacobi or Gauss-Seidel? Till now, we have not discussed regarding the procedure, but let us consider this problem. Okay, now 4x3 equals to 9. Okay, 8x1 minus 3x2 plus 2x3 equals to 20, and 4x1 plus 11x2 minus x3 equals to 33. Roll number 33. Are you there? Roll number 33. Not there. Okay. So roll number 20. Next. Roll number 9. Just see the signature. Okay. Roll number 32. Roll number 30. Roll number 29.
Yes, sir.
Yeah. So 29 only. So 29, 32, 30. Is it diagonally dominant? The system is diagonally dominant or not?
No, sir.
No. Fine. Good. So why it is not diagonally dominant?
Because in first row and third row.
Okay, first row. Let us consider first row. Okay, now one row. No need to check all the rows. Okay, now at least if one is not satisfying, means no need to check the others. Okay, so
Yes.
can I? It should be correct now. This is the question mark. Is it? Yeah, 1 plus mod of 4. So mod of 1 means 1 greater than equals to 1 plus 4. Okay, that means 1 greater than equals to 5. Is it true?
No, sir.
No. So the system, correct now? The system is not diagonally dominant. Fine? Okay, fine.
Yes, sir.
Fine. Now, okay. Rule number 23. How actually I'm considering this roll number? You just see the combination or arrangement of these numbers only. Okay. So roll number 23. Not that. Okay. Okay. 39.
Yes, sir.
Yeah. Is there any possibility to make it diagonally dominant? Just go through the equations and just tell me. Try to answer. Okay, now.
Yes, sir.
Otherwise, I will discuss it. It's not a problem. Okay. So just see, if we change the position of the equations, okay, that means this one and this one to the third one last. Okay. So this is the first equation. Now this is the second equation. This is the first equation, correct? This is the second equation. This is the third equation. If we rearrange the system, okay, if we rearrange the system, can we make the system to a diagonally dominant system?
Yes, sir.
Okay, roll number 39, na?
Yes, sir.
Okay. How? Tell me the arrangement. That means the serial number now. 2, 3, 1. Yes or no?
Yes, sir.
So 2, 8x1, if you make this one, so what is that one? Now, if you change, you know the that properties of the matrix, okay, will not change if you change or if you exchange the position of the rows. Okay. So this matrix, these equations, if you write first, okay, now the changes positions are, okay. So let us consider this one, the new position, okay. This one is the second position and this one is the third position. Okay, so what is the new position? That means 8x1, the new, after rearranging the equation, 3x2 plus 2x3 equals to 20. Second equation is, second one is, what is that one? 4x1 plus 11x2 minus x3 equals to 33. And finally, okay, x1 plus x2 plus 4x3 equals to 9. If this is the same system of equation, now we have rearranged to this equation, correct? Now it is diagonally dominant or not?
Yes, sir.
Yes. So this is now diagonally dominant. Okay. How it is? Now you just check it. Mod of 8 greater than equals to mod of minus 3 plus mod of 2. Similar case, mod of 11 is greater than equals to mod of 4 plus mod of minus 1. And the final one is mod of 4 is greater than equals to mod of 1 plus mod of 1. So the system is diagonally dominant. That means if after rearranging also, if we are not able to write or not able to find this diagonally dominant properties, okay, is satisfied, then you can say the system, this system, okay, you can't apply Gauss-Seidel or Gauss-Jacobi method. Okay, so this is the first criteria to solve the system of equation using Gauss-Jacobi or Gauss-Seidel. Fine. Okay. Now, first one is that method is Gauss-Jacobi. What is that one? Okay, now Gauss-Jacobi method. Okay. So already you know that first you have to check. Okay. Check the system is diagonally dominant or not. Fine. Second one, the procedure. Okay now. So now I will consider only say 3 equation and 3 unknown. Okay, it will be easy for you to. Okay, x1 a12 x2 a13 x3 equals to b1. Okay, a21 x1 plus a22 x2 plus a23 x3 equals to b2, and a31 x1 plus a32 x2 plus a33 x3 equals to b3. I have considered only 3 equation, 3 unknown. Okay, I hope you can extend that one for up to n number of equations and n number of variables. Okay, if you understood this system, then it's fine. So now the second step. Okay, now the system is rewritten. Okay, now how to rewritten this form? A11. Okay, x1. Correct. So what will be the answer? That will be now b1 minus a12 x2 minus a13 x3. Okay, so write down this one in that form. A11, this is the form. Okay, so this one. In similar way, you can write all this system of equation. This is the second one. Okay, the write down x2. Okay, so a22 sorry, b2 minus a21 x1 minus a23 x3, and finally x3 1 by a33 b3 minus a31 x1 minus a32 x2. I think you can able to write if it is more than 3 variables. Correct. So first equation you write in terms of say x right hand side for the other variables, the left hand side for the second equation for the variable x2, and third equation x3 for the variable x3, and so on. So this is the first step to write in that form. Okay now. So what will be the, so now since we know that these are the iterative process. Okay, so first you need the input for this one. I repeat, to find x1 you need these 2 input. To find x2 you need these 2 input, initial one, and this to find this one. That means x2 x3 x1 x3 x1 x2 all are known. That means actually should be given. That means x1 x2 and x3 all 3 are required. Okay, so you need the initial approximation, that is called either initial input or initial expression. Okay, the initial approximation should be given. Let us consider it will be given in the problem. Otherwise, if it is not given, you can choose. Okay, so initial approximation solution should be given. Solution should be given. Should be given. If it is not given, then you can choose. So let us consider this one is 0. All are given as a 0. Let us consider 0 0 0. Then you solve it. So this is the first initial input. Okay, sorry, initial input, and it should be denoted like that: x1 0, x2 0, x3 0. Okay, so that one. Okay, so now after if you input all this one initial approximation, you will get one set of solution. Fine, the next set of solution. So that solution, after solving, we get x1 1, x2 1, x3 1. Any doubt? So the initial given approximate solution is 0, 0, 0. And if we put 0, 0, 0, you just see b1 by a11, b2 by a22, and b3 by a33. If it is non-zero, then some other particular value you will get. Okay, now. So after that, if you solve it, you will get this one, x1, x2, x3. So this is called first approximation solution. Fine. Then what will be the second approximation solution? Anyone?
Sir, we will substitute x11, x21, x31.
Yeah. Then if we input this one, that means since it is actually iterative method, okay, now you know that one. So since it is iterative method, if you give this one in the next step, okay, this one as input, okay, and if you solve the system, the above system, then you will get one more solution. And what will be the notation of that solution? x1 2, x2 2, and x3 3. Correct. So you just see like indices now, that is actually the number of iteration. Correct. So if you give this one as input and this one is output, then your new math, that equation will be like that. You just see it. Okay, 2, 2, 2. This one will remain same. This one is 1, 1, 1, 1, 1, and that one here as well. Here also 1. Fine. So if you continue or if you repeat this process up to say kth time, okay, so okay, if you continue this one, okay, then up to kth time, then the k plus 1 solution is, okay, so what will be the k iteration process? So x1 k plus 1 is a11 b1 minus a12 x2 k minus a13 x3 k, x2 is k plus 1, means k plus 1 solution, okay, so is equals to 1 by a22 b2 minus a21 x1 k minus a23 x3 k, and finally x3 k plus 1 1 by a33 b3 minus a31 x1 k minus a32 x2 k. Fine. Fine. So this is the iterative formula, or it is known as working formula. Anyone having any doubt? This is actually known as iterative formula, or it is sometimes it is known as iterative formula or working formula. Okay. Anyone? Any doubt? This is working formula, or sometimes it is known as actually iterative formula. Sometimes it is known as working formula also. Okay. Yeah. Very good question. Okay, actually. So you are asking regarding this one, correct? Okay. No, this one, initial value. Okay, na? This one. Okay. So in the question, if it is given, fine. If it is not given, then very good question. Say the x1 So 3 equals x1 0. Okay, x2 0. You are expecting that this should be given, correct? Fine. So let us consider this one is not given. Then what you have to do? Then yeah, you can take arbitrarily any value. But if you know the solution, so in the last 2 classes we have considered such a problem. The answer is 3 2 1. Okay. So if you consider this one is say 3, original solution is say 3 2 1. Let us consider. If you are considering this one is 3, original solution. This is the original solution. Okay. And if your approximation, initial approximation is same, can you improve this one, the solution? The exact solution is also 3 2 1. Are you able to improve the solution? Then what you have to do? That means what should be your initial approximation? That is the question. Okay. What is your initial approximation? Just guess it and tell me. It is, I have already stated that one, that you can take arbitrarily. Okay, now. So what is your choice? Tell me. Very good. That is one of the very simplest way. Another one? Anybody else?
I'll take it as 1, sir.
Okay, fine. Or I know you, if you are 59 are there, your choice will be different. Sure. Yes or no? Yes. If you are not sitting together, okay, na? Then actually it does not depend on this solution or this approximation. Okay. Surely you will get this solution only. Okay. But if you consider far away of the original solution, then your number of iteration will be more. Correct? So you try to take very close to that one, but not exact one. So one fellow told 2 2 1 1 1. Fine, good one. That is good approximation. Or another fellow is 0 0 0. That is the best approximation. I can say that initial approximation. Okay. Since you don't know, it is not possible to solve always. Okay. That if it is 4 cross 4 problem or 5 cross 5, and it's really tough to check the original solution. What is the exact solution? That means not original, exact solution. In that case, you just took 0 0 0 0. Nothing. It's better. You have to consider 0 0 0 as an initial approximation. That will be the better one. Okay. So now the question is, this is your k plus 1. So this is it is actually the iterative formula. These are the iterative formula. Now, when you should stop? How many means iteration you have to do? Okay. Any guess?
While repeating the same process, we will get the same solution, sir. Then we will stop.
That is actually the most popular stopping criteria for any iterative formula. What is your roll number?
51, sir.
51.
61.
61. Okay, fine. Okay. So actually, for any programming, if you go there, actually you can check it that for the case of iterative process, not only numerical. I'm telling you about any solution. Okay, na? Any type of solutions. It may be linguistic solution, it may be a numerical solution, it may be some other solution. That is the actually best criteria to stop the iterative formula. That means, say your 5th iteration solution is 3.01, 2.1 and 1.1. 6th iteration also the same, 0 1, 2.1 and 1.1. Okay, then you can stop. The question is another, it's fine. Another stopping criteria is for this numerical type of solution. Okay, there will be a note on that. Okay, now in your question. Okay, now stop or find correct 2 decimal places. 2 decimal places. Okay, that means you no need to check. Say the answer is, your 5th iteration answer is this one, 1 3 1. Okay, and then your criteria is say correct up to 2 decimal places. So let us consider that your next iteration solution is, I will write here. Okay, the next iteration, this is the, sorry, so 211, say 1.112. Let us consider these are the 011. These are the 5th iteration solution. Your criteria, stopping criteria is correct up to 2 decimal places. 2 decimal places. So in that case, what will be the answer? So you can just check it. Say the, okay, this one 3011, 2.113, 1.112. Okay, 3 decimal places. And your next, this is the 5th. The 6th iteration is say 3.015, 2.114, 1.116. Can you stop your can you stop here? Yes. Why? Your criteria is, stopping criteria is correct up to 2 decimal places. That's it. But if the criteria is correct up to 3 decimal places, so for 2 decimal places it is okay. Okay. So sorry, 2 dp, 2 decimal places, it's fine. Now if it is 3 decimal place, then you can't stop here. You just check 3. It's not matching. It's not matching up to 3 decimal places. So you have to check for the 7th iteration. You have to go for the 7, 8, and so on till you are getting 3 decimal places same answer. Say let us consider 7th iteration is 3.015, 9 at 2.1146, 1.1169. You can stop here. 3 decimal places, actually the result are same. Okay, so you can stop here. So these 2 are the stopping criteria. One is, okay, that 2 successive iterative iteration you are getting the same result, or else if it is given either 2 decimal places or 3 decimal places, that case. Okay, so now next one is, consider one problem, and will, or else another option will may be there. Find up to 3rd iteration. That means whatever may be the solution. Okay, another point is, okay, find up to 4th iteration. That means after 4th iteration you can stop. Okay, that is the 3 main criteria. Okay, now or stopping. So should have pen and paper, correct? Sorry, calculator. Okay. So now first, problem 1, using Gauss-Jacobi. Okay. Okay. Just wait, before that, what is the time? 10 o'clock, 9:20. Okay. Okay. Now first you consider one problem. Solve the system. Solve the system of equation using Gauss-Jacobi method. Why is this one here? Gauss-Jacobi method. Fine. So, what is that equation? Same equation. Just a few minutes back, we have already discussed. X1 plus X2 plus 4X3 equals to 9. Okay. Then 8X1 minus 3X2 plus 2X2. Sorry, 2 equals to 20. 4X1 plus 11X2 minus X3 equals to criteria is given, but initial approximation is not given. Okay, up to 2 decimal places. Okay, 2 decimal places. Fine. So, what are the first observations? No initial approximation. No initial approximation. Correct na? Initial approximation is not given. Okay. Then it is, for this case, it is your choice. You can choose arbitrarily any value. Okay na? So that is the case. We'll remove. Finish. Okay. Now solution. Mod of 1, sorry, here mod of A11, okay, A greater than equals to mod of A12 plus mod of A13. Is not correct. So 1 greater than equals to mod of 1 greater than equals to mod of 1 plus mod of 4. Okay, so that implies mod of 1 is not greater than equals to mod of, sorry, that implies 1 not greater than equals to 5. Okay, therefore the system of linear equations okay, is not diagonally dominant. What will be your next step? Fine, not diagonally dominant. Now we rearrange the system as follows. Okay, so just check here. We will write the rearrange the system as follows. What is that one? Now 8x1 plus, sorry, minus 3x2 plus 2x3 equals to 20. Okay, then next one is 4x1 plus 11x2, okay, minus x3 equals to 33, and x1 plus x2 plus 4x3 equals to 9. This one. Okay. Now the system is diagonally dominant since mod of AII is greater than equals to summation of mod of Aij for I equals to 1, 2, and 3. I not equals to j. Is it? You can check it. So mod of 8, next one is next slide. Okay, mod of 8 is greater than equals to mod of minus 3 plus mod of 2, then mod of 11 is greater than equals to mod of 4 plus mod of minus 1. Okay, and finally mod of 4 is greater than equals to mod of 1 plus mod of 1. Okay, all are correct, all are holding. Okay, so now therefore the system can be solved using the Gauss method. Okay, therefore now the iterative the iteration formula, okay, for the method is, I'm writing actually what you should write in exam, everything, okay. K plus 1 equals to 1 by 8, 20 plus 3x2k minus 2x3k, okay, x2 k plus 1 equals to 1 by 11, okay, yes, 1 by 11, 33 minus 4x1k plus x3k, and x3k plus 1 equals to 1 by 4, okay, 9 minus x1k minus x2k. Any doubt? Okay. Now, roll number, say 4. Roll number 4.
Yes, sir.
Yeah. Tell me, what is the initial approximation for this system of equation for the Gauss-Jacobi method? It is given or not? It is given, na? What is the
Yes, sir.
what is that one? Actually, it is there in first slide. Okay, I am now in second slide only. Yeah? So I can't go back. You just tell me what is the initial approximation as per this problem. Okay, what is that? So let the initial approximation, correct na, or initial solution, okay, is x1 0, x2 0. It is given or not? And if it is given, what is that one?
0, 0 and 0, sir. X1,
Zeta.
0, 0.
Okay, rule number 8. What is the initial solution for this problem? Rule number 8.
Yes, sir.
What is the initial solution for this problem? It is given or not, first of all? Okay, rule number 11. Okay, fine. So if we go back, just check it. I have already written here actually, I now erased it. Okay. No, it is not given. Correct up to the stopping criteria is given. Correct up to 2 decimal places. But here it is not given regarding here there is not given any information regarding the initial approximation or initial solution. That means 0, 0 solution. So that means next one. These are not given. So what actually I told you can choose arbitrarily as per your choice. So now you choose rule number 4. Tell me what will be the initial solution, and based on that we will proceed for this solution. 1 1 1. Told I think so. Correct. 1 1 1.
Yes.
Or something different. You just tell me 0 0 0. We can consider. Correct. Let us say 0 0 0. Huh?
Yes. Yes, sir.
No. Your choice. You tell me. Why 0 0 0 or 1 1 1?
0, 0, 0.
Now mix it up. Okay, now 0 0 and 1 1. Some are 0, some are not 0. Then let us see
Okay,
what.
sir.
Tell me then. X1 is. Tell me your
0.
0. Okay. X2.
0,
This is also 0. Okay. X3.
1.
Okay, fine. So 0 0 1. Okay. So this is the initial input. Let the initial solution or initial input values are this one. So I have to erase it and I have to write again. Okay. So 0 0 1. Fine. So x1 is 0. So this is your choice. If it is not given, if it is given, you can't change that one. So now first solution, correct now. So it will be the first solution. Okay. So first iteration, I will go to the next. So you have to put 0, x1 is 0, x2 is 0 and 1. Then that means what is that one? K equals to 0 solution. So what do you have to put? Now for k equals to 0, I will go back next. It a first iteration. First iteration. So put k equals to 0 and the initial approximation or initial solution is 0, 0, 1 as per your friends. Okay now. So now if k equals to 0, previous you just take. So the formula is k1 1, k is 0, 1 by 8, 20 plus 3, x2 0. I will write the first case only. Okay, next onwards the same procedure. Okay now. So x1 0 plus 1. So I should not write 0 plus 1. Okay. So let us consider that one is 1. Okay, that is 1 by 8. Okay, first case only, this case only I am writing. Next onwards I will not write. Okay now, in details I will put the value 3x2 0 minus 2x3 0. Okay, x2 1. Okay, this is 1 is 1 by 11. Okay, 33 minus 4x1 0 minus plus x3, it is 0. So here it is x1 0, x2 0 and x3 0. This one equals to this one. Okay, now x3 1 is 1 by, what is that one? 1 by I think so 1 by 4. Okay, 1 by 4. Okay, 1 by 4, 9 minus x1 0 minus x2 0. Okay, this one. So first iteration I am writing in details. Other next iteration onwards I will not write details. So now x1 1. What is the answer? Okay, this 5. Fine. 1 by 8, 20 plus 3 into 0 minus 2 into 1. Correct. So x2 is, so this solution depends on your initial conditions. Okay, now if you have considered 0, 0, 0, your answer will be different. Okay, and for that you no need to actually, should not be worried. Okay, now for that plus 1 into 1. x3 1 is 1 by 4, 9 minus 0 minus 0. What is the answer then? x1 1. For this one, you just follow this problem. You follow me only. Rest one you choose. You can choose your input if it is not given. And okay, this is for practice only. So x1 1. What is the answer? Quick. 19 by 8 or 18 by 8. Okay, so 9 by 4, correct? Yeah, x2 1.
34 by 11.
34 by 11. Fine. And now x3 1. 9 by 4.
1 by
Fine.
4.
So now go to the next. I will do one more iteration, then I will stop. Rest part you have to complete. Okay now. So next one, second iteration. Okay. Iteration. x1 1. Can you repeat it? What is the answer? Previous one. 9 by 4, 30 by 4 by 11, and x3 9 by 4. So now x1 2. I will not write that expression. Okay, now directly you can write like that: 1 by 8, 20 plus 3 into your answer. Okay, minus 2 into your answer, previous one. x2 2, second iteration, k equals to 1, correct? And this one, second iteration, k equals to 1, and x1 1 is 9 by 4, x2 1 by 34 by 11, x3 1 by 9 by 4. 1 by 11, okay, 33 minus 4 into plus, okay, plus, that is one is that one, plus that one, I don't know that answer. Okay, that is actually x3, so 9 by 4, correct? 9 by 4. What is 3 into x2? So x2 is 34 by 11, correct now? x2 only, yes. And minus 2 into x3, x3 is 9 by 4. Here it is x2 minus 4 x1, correct? x1 is 9 by 4. x3 2, 1 by 4, correct? 9 minus x1 means 9 by 4 minus x2 minus 34 by 11. Therefore, x1 2, what is the answer? Should have calculated, otherwise it will take a lot of time. Okay. Ready? What is x1 2, x2 2, x3 2? Quick. One minute, beta. 1 0. Okay, you can now can make it in decimal places. That will be better. Okay. Okay. So since you have to consider, you have to check up correct up to 2 decimal places. At least 2 more should be there. So you just write down up to 4 at least minimum. 6 5, fine. What is your roll number? 42. Okay. 42. Good. So x2. Anybody else or 42 also you can also answer.
2.3863, sir. 2.3863, sir.
3863. Okay. What is your roll number?
29, sir.
Okay. Next, x3.
x3 equals to 0.9147, sir.
47. So you understood that concept now. So concept is for all of you. Okay, you have to find correct up to 2 decimal places. So should we consider only 2 decimal places for the iteration, intermediate iteration? No. Then it will take 10, 20, 30 iteration. At 2 decimal places means for so to minimize the error, actually you have to consider at least 4 decimal places. At least. If you consider more than that, your actually convergence rate of this iteration will be increased. Okay, so okay, let us consider 4. 4 is also correct, no problem. So now I think this is the second iteration. Now I will not write the third iteration and so on. Okay. So third iteration, you have to find the third iteration. Okay. So for the third iteration, okay, what is the k? Now k equals to 2. You put k equals to 2, previous one. Here, if you put k equals to 2, then it will be x1 3, x2 3, x3 3. Here it is x2 2, 2, 2, 2, 2 and 2. So this is the new iteration formula for the iteration. This one actually. Okay, clear? So, okay, next. So that will be the next iteration formula for the third iteration. And k2 is 2, x1 2 is this one 3.0965, x2 2 is 2.3863, and x3 2 is 0.9147. And if you substitute these input values in the new iterative formula, then you will get x13, okay, x23 and x33. This thing. Okay, it will take some time. You can find it. Okay, since you have next class, I think so. So I will not find this one, and I will not wait for your answer also. If you anybody having the answer, you can answer right now. Okay, I will write here. Otherwise, you can find it. So that is the right now you are in third iteration. So what is the stopping criteria? Now 2 decimal places. Now your answer, if your answer is 0.3.09 or something, okay now, and 2.38 and some other decimal, 91, this one, then you can stop here in the third iteration. If it is not like that, okay now, then you have to go for the fourth iteration or so on. Okay, fourth iteration and so on. So stopping criteria is 2 decimal places. So whenever your two successive iteration, second iteration and third iteration, or third iteration or fourth iteration, you can stop. Okay, if two successive iteration giving the same 2 decimal places, okay, the same 2 decimal places, numerical result are same, then you can stop there. Otherwise, you have to proceed for the next iteration. Okay, so this is the Gauss-Jacobi method. Anyone having any doubt? Okay, first one is, now this is, you have to complete, this is one of your, actually you have to complete this one. Next, one more homework. Okay, so only one, this one. Okay, correct up to 2 decimal places. Use, okay, solve the system, okay, system by Gauss-Jacobi method. Okay, correct up to 2 decimal places. 2 decimal places. Okay, 2 decimal places. Here also the initial approximation is not given. 20x1 minus x2 plus x3 equals to 23.28. 2x1, okay, plus x2 minus 20x3 equals to minus 55.64. Next, x1 plus 15x2 minus x3 equals to 29.92. Okay, make a group, WhatsApp group, okay now, and send this solution. Okay, make a group first. Okay, here are there anyone?
Yes, sir.
What is your roll number, ma?
Roll number 4, sir.
4. Okay. You create one group, WhatsApp group. Okay. Math,
Okay, sir.
like math, and you give the name. Okay, na? Math 252 or math MA252 or anything according to your choice.